Welcome to an exciting journey through Python's treasure trove of built-in modules. Python comes packed with powerful tools right out of the box: modules for mathematics, random number generation, file operations, web requests, and so much more. Today we'll discover these hidden gems that can save you hours of coding and make your programs more powerful and efficient. Before diving into specific modules, let's understand what modules are and why they're so valuable. A module is simply a file containing Python code, functions, classes, and variables that you can import and use in your programs. Python's standard library contains over 200 modules, each solving common programming problems. Here are just a few of Python's built-in modules. Each one is like a toolbox filled with specialized functions. The math module handles mathematical operations. Random generates random numbers. Datetime works with dates and times, and so on. You access these tools using the import statement, which loads the module into your program. Let's start with the math module, your gateway to advanced mathematical operations. While Python handles basic arithmetic naturally, the math module provides functions for trigonometry, logarithms, factorials, and mathematical constants. It's essential for scientific computing, engineering calculations, and any math-heavy applications. The math module is packed with useful functions. It provides mathematical constants like pi and e. Basic functions include square root, power, and absolute value. Rounding functions like ceil and flow are perfect for converting floats to integers with specific behaviors. Factorial calculates the product of all positive integers up to a number. Trigonometric functions work with radians, so you often need to convert from degrees. Logarithmic functions support natural log, base 10, and base 2. Here are practical applications of the math module. Calculate distances using the Pythagorean theorem with SQRT. Use pi for geometric calculations like circle areas. The exponential function handles compound interest and growth calculations. These examples show how math module functions solve real-world problems elegantly. The random module is your toolkit for generating randomness, essential for games, simulations, statistical sampling, and adding unpredictability to your programs from simple dice rolls to complex probability distributions. Random has you covered. Random module functions cover many use cases. Random gives floats between 0 and 1. Randint includes both endpoints, while randrange excludes the stop value. Uniform generates floats in a range. Choice picks one item from a sequence. Choices allows multiple selections with replacement, while sample selects without replacement. Shuffle randomizes list order in place. Seeds make randomness reproducible for testing. Here are practical random applications. A dice game uses randint for fair rolls. Password generation combines random choices with string constants for security. Monte Carlo simulation uses random points to estimate mathematical constants like pi. Random data generation creates test datasets with realistic but random values. These examples show how randomness enables simulations, games, testing, and security. Working with dates and times is a common programming challenge. The datetime module provides classes for manipulating dates, times, and timestamps. Whether you're logging events, scheduling tasks, or calculating time differences, datetime is essential. Datetime module has several key classes. Datetime represents both date and time. Date and time classes handle just dates or times. You can create specific dates and times by providing year, month, day, and optional time components. Time delta represents time differences, perfect for date arithmetic like adding days or calculating ages. String formatting with staff time lets you display dates in any format you need. First, let's calculate age from a given birth date. It correctly adjusts for birthdays that haven't yet occurred this year. Next, business days calculator. It skips weekends by checking weekday values, ensuring deadlines are realistic. DateTime also handles time zones and timestamps. Here we print the current UTC time and convert between DateTime and Unix timestamp. Event scheduling is another powerful use case. We calculate how many days, hours, and minutes remain until a conset. Finally, log formatting. It generates clean log entries with professional timestamps, commonly used in debugging and monitoring systems. These practical datetime patterns, age calculation, business days, time zones, event scheduling, and logging, are widely used in real-world applications. The OS module bridges Python with your operating system. It handles file paths, directory operations, environment variables, and system commands. Whether you are building command line tools or managing files, the OS module is indispensable. First, basic directory operations. getCwd shows your current working directory, while listdir lists all files and subfolders. Next, file and folder operations. You can create, remove, and rename files or directories. These are the building blocks of automation scripts. Path operations are essential for cross-platform scripts. Join builds valid paths. Dirname and basename extract folder or file name. And splittext gets file extensions. Before performing operations, always check existence. OS, path, exists prevents crashes. And isfile or isdir help distinguish files from folders. You can also read environment variables like path or home, and detect the operating system using os.name. This makes your code portable across platforms. A practical example is a file organizer. It groups downloads into images, documents, and videos using extensions. Another application is a backup script. OS walk scans entire directories and recreates folder structures during backup. Finally, a system configuration checker. It collects OS name, home directory, and other settings, useful for diagnostics. Together, these tools show how the OS module powers automation, file management, backups, and system scripts in Python. JSON, JavaScript Object Notation, is the universal language of data exchange. Python's JSON module makes it effortless to convert between Python objects and JSON strings. This enables communication with web apps, configuration files, and data storage systems. First, we define a Python dictionary. Using JSON dumps, we serialize it into a JSON string. This is how Python data gets prepared for apps and storage. By adding the indent parameter, dumps creates human-readable, pretty printed JSON. This is especially useful for debugging or storing configs. The reverse is loads, which passes JSON back into Python objects. Here we extract the name and list of skills from the JSON string. For real applications, use dump and load with files. Dump writes JSON to disk, while load reads it back into Python. But JSON only supports basic types like strings, numbers, lists, and dictionaries. Objects like datetime cause errors. The solution is to provide a custom serializer function that converts them into strings. In summary, JSON modules dumps, loads, dump, and load cover most use cases. Pretty printing helps readability. File support enables persistence. And custom serializers handle complex objects. That's why JSON is the backbone of data exchange in modern applications. JSON is everywhere in software. Let's see 3 real-world applications: configuration management, API response handling, and data logging. First, configuration management. JSON files store app settings, easily loaded with sensible defaults. Next, API responses. JSON is the standard format for REST APIs. You can pass, check status, and extract results. Finally, data logging. JSON provides structured logs that are easy to query and analyze. Together, these examples show why JSON is the universal choice for configuration files, APIs, and logging. Python's standard library contains many more powerful modules. Let's quickly explore several essential ones. The remodule handles pattern matching, great for email validation and text parsing. Collections offers counter for frequencies, default dict for auto defaults, and dec for fast queues. itertools provides combinations, infinite counters, and tools for chaining iterables. Pathlib gives object-oriented, cross-platform path handling, far cleaner than OS path. Erlib makes basic web requests and encodes URLs. For complex HTTP, requests is preferred. Together, these modules cover text parsing, data structures, iterators, file system paths, and networking basics. Understanding different ways to import modules is crucial for writing clean, efficient code. Full module imports keep namespaces clean. Aliases shorten long names. Specific imports remove the need for prefixes, but can clutter the namespace if overused. Star imports pull everything into the namespace, and are best avoided. Conditional imports adapt to Python version differences. Try except imports let you handle optional dependencies gracefully. Local imports bring in heavy libraries only when the function is called, saving resources. Sometimes you need error handling for version-specific features. Provide fallbacks where possible. Finally, here's a summary of best practices for imports. Understanding built-in modules naturally leads to creating your own. Modules are simply Python files that you can import. Let's begin with some string utilities. Now we add math utilities to our module. Classes inside modules can store configuration and state. Using custom modules is just like using built-in ones. For larger projects, organize modules into packages. This folder structure keeps everything clean and reusable. As your programs grow, understanding module performance becomes crucial. Some modules import quickly like math and JSON, while others like re and collections take longer. Each imported module increases memory usage. We can inspect loaded modules and their attributes. Lazy loading imports modules only when first used, saving startup time. Dependency checks ensure required modules are present and help handle optional ones gracefully. Python caches imported modules, so multiple imports reuse the same object. Here is a checklist for performance, organization, error handling, and code quality. Finally, use virtual environments to isolate dependencies and avoid conflicts across projects. Python's built-in modules are incredibly powerful tools that can solve most programming challenges. Without external dependencies, every module you master makes you more capable and productive. The key is to explore, experiment, and build real projects. Don't feel overwhelmed by the vast standard library. Learn modules as you need them for your projects. The Python documentation is excellent, and the community is always ready to help. Most importantly, remember that many problems have already been solved by Python's standard library. Check what's built in before reaching for external packages. Thank you for joining this comprehensive tour of Python's built-in modules. You now have the knowledge to leverage these powerful tools in your own projects. Keep exploring, keep building, and remember that the best way to learn modules is by using them to solve real problems. The Python standard library is vast and powerful. Make it your ally in creating amazing software. Happy coding and happy module exploring.